Okay, inclined planes with pulleys. So the first thing we're going to do is treat it just like we have all of the other inclined plane problems, and we're going to create an XY axis. Remember your x-axis, if you take it up the plane, now we're going to just continue to wrap it down through the pulley. Okay, it's kind of like what we did before with the pulleys, where there was no inclined plane, but we would take the pulley and flatten it out. We're doing the same thing now with the inclined plane. We're just going to pretend that that's all one axis. This is our x-axis. I'm going to just arbitrarily call this the negative direction. I'm going to assign this as being the positive. I won't know which direction is positive or negative until I know which direction it's going to move. And that's going to depend on whether mass 2 is large enough to overcome the force from gravity based on this angle and the mass for mass 1. I'm going to draw in my y-axis just like I did for my other inclined plane problems. Okay, and then I'm going to start identifying the forces. For object 1, mass 1, we have normal force pushing up. We have the force of gravity pulling it straight down. And then we can split force of gravity into FGY. We call it FG1Y, so we know that's from mass 1. And we have FG1X, if we put it into components. And then if we were to isolate just mass 1, we have one other force acting on it, and that's the strain. Right here, pulling it up the ramp. So that's our force of tension. Okay. We don't have friction in these. They're just inclined planes with pulleys with no friction first. Okay, so if we're to sum forces for mass 1, we'll start with the y direction. Sum forces in the y direction for mass 1, we get Fn, that's an equal sign, Fn minus Fg1y equals mass 1 times acceleration in the y direction, and it's not going to float off the plane or sink down through it, so that's equal to 0. And then we could substitute in, we have Fn minus m1g cosine theta equals 0. And if we're solving for Fn, we can just, Fn equals m1g cosine theta. Okay. Then we can sum forces in the x direction for mass 1. Sum of forces in the x direction for mass 1 is, I'm going to arbitrarily, like I said, call this direction positive. I don't know yet if it goes up or down the slope. But we'll call F tension the positive direction minus Fg1x. Nothing else is acting on it because we don't have force of friction, equals m1 acceleration in the x direction. Okay, we don't know our force of tension. We can substitute in for that, m1g sine theta equals m1 acceleration in the x direction. If I'm asking you to solve for acceleration, we have a problem now because we have two unknowns and we can't solve through for that. I'm going to isolate mass 2. Okay. So on mass 2, I have the force of gravity for mass 2, Fg2, pulling it down, and I have force of tension trying to pull it up. Okay, but we assign down as being the positive direction for this one. So if we sum forces in the x direction for 2, even though it's vertical, we're calling it the x direction because remember we're flattening it out. So sum of forces in the x direction for number 2 is Fg2 minus force of tension equals m2 acceleration in the x direction. Okay, once again, Fg2 is just m2g minus force of tension equals m2 acceleration in the x direction. I can combine these two equations to get rid of my force of tension. So if I add this equation for mass 1 and this equation for mass 2, our force of tension will cancel out, and I'm going to get m2g minus m1 g sine theta equals m1 plus m2 times acceleration, I'm running out of room again, just like it work, times acceleration in the x direction. Okay? This equation comes from adding this and this, right? I could also find this by taking the entire system in total. So if I take purple and I view this entire system, I know it's hard to differentiate with all these things going on, but if I were to take mass 1 and mass 2 together and sum forces across the x direction for the system, I'm going to get force of tension internalized, like we've talked about before. That's why it drops out, because if I were to add these two together, it just cancels out. So now I can look at it and say I have Fg1x pulling it downhill, so negative, plus Fg2 pulling it down in the positive direction equals mass of the system times acceleration in the x direction. And then if I substitute in, we have negative m1 g sine theta plus m2g equals m1 plus m2 times acceleration in the x direction. So this and this are the same thing, right? Just in a slightly different order. Okay. If we can get it down to this, we can solve it for the acceleration. We could divide through and have our acceleration in the x direction. And I'm going to erase something because I'm probably going to cut off this entire thing at this point. Okay, so I'm going to take this proof out. And we're just going to rearrange to get our acceleration. So acceleration in the x direction equals m2g minus m1g sine theta over our combined mass of m1 plus m2. Okay, and then we can just plug in and solve for our acceleration. If we need to know our force of tension, we now know our acceleration. We can solve this and find our force of tension. We could also solve this to get our force of tension. The best thing to do if you have spare time is to solve both of them and make sure that it works out the same. If it's not working out the same, it means that you have assigned your signs incorrectly. You've assigned a direction on a force wrong, or you've plugged in an acceleration as a positive when it's a negative, or as a negative when it's a positive. So it's a fast double check, and if your force of tensions don't work out equally, you know you messed up someplace along the line in the problem. Okay, I'm going to cut the video here and give you guys a set of numbers to put in, and I'm going to ask you guys to solve for acceleration and force of tension if you're given the following. If theta equals 30 degrees, m1 equals 5 kilograms, and m2 equals 1 kilogram. Okay, go ahead and solve for the acceleration and the force of tension on that. The next video will show the calculation for that, and you can see if you're getting your calculation of the problem correctly.